our topic is about fundamental trigonometric identities. Now, for your information, there are many trigonometric identities, but I want to present only few of these trigonometric identities. And these trigonometric identities are the identities that we usually use when we discuss some of the concepts in calculus. For example, we have the fundamental identities. Now we have the reciprocal identities. Now this is defined as cosecant t is equal to 1 over sine t. Okay, so familiarize this formula. Cosecant t is equal to 1 over sine t. Now recall in the previous video, we have defined that cosecant t is equal to 1 over y, right? And since y is equal to sine of t, so that y can be substituted by sine t. Okay? So secant t is equal to 1 over cosine t. And again, this is defined before as 1 over x, right? And since x is defined as cosine t, so x there is substituted by cosine t. Now, cotangent t is equal to 1 over tangent t. Okay? Tangent t is equal to sine t over cosine t, and this is defined as y over x also. Okay? Now, cotangent t, this is another definition of cotangent t. This is equal to cosine t over sine t. Because here, this is 1 over tangent t, right? Now, tangent t is equal to what? Sine t over cosine t. So, you get the reciprocal, then you will have cosine t over sine t. Then the next one is Pythagorean identities. So sine squared t plus cosine squared t is equal to 1. So you have to remember this. This is very familiar, and this is used in most of the problems in calculus. Okay. So we have also tangent squared t plus 1 is equal to secant squared t. And we also have 1 plus cotangent squared t is equal to cosecant squared t. Okay, so these are the basic trigonometric identities. So we have here an example. Now, if cosine t is equal to 3 over 5 and t is in quadrant 4, find the values of all the trigonometric functions at t. Okay, how can we solve this problem? We are given that cosine t is equal to 3 over 5. And with the condition that t lies in quadrant 4. Okay? So find the values of all the trigonometric functions at t. How can we solve that one? So what's the possible trigonometric identities, okay, that can be used in solving this problem? So for that solution, for our solution, recall that from the Pythagorean identities, we have sine squared t plus cosine squared t, which is equal to 1, right? Okay, so we can use this trigonometric identity. Why? Because we are given that cosine t is equal to 3 over 5. That's the given. That cosine t, or that's the condition, that cosine t is equal to 3 over 5. And since we have this formula, so therefore, we can substitute the value of cosine t, which is 3 over 5, to this expression. Okay? Because sine squared t plus the value of cosine t, which is 3 over 5, then you square that one. Why? Because of this formula that we have to square cosine t. Then that value is 3 over 5. Okay? Now, for your information, cosine squared t is just equal to the quantity of cosine t squared. Okay? So this one is just equal to 3 over 5 squared. So this means that cosine squared t, this means that cosine t times cosine t. And the notation for that is cosine squared t. So this is also mean as sine squared t is sine t times sine t. Okay? So if we have cosine t, which is 3 over 5, and we have cosine squared t, therefore, we have quantity 3 over 5 squared, then equal to 1. Okay? Then you solve for the values of sine of t. So we have sine squared t plus 3 over 5 squared. This is 9 over 25, right? So sine squared t equals 1 minus 9 over 25. Okay, you combine like terms, you combine all the constants. So we have sine squared t is equal to 16 over 25. Okay, now since we have sine squared t, which means sine t times sine t, so um, we can use the square root or take the square roots of both sides. That is, get the square root of sine squared t, then this is sine t only. Then the square root of 16 over 25, okay, is equal to plus or minus 4 over 5. Am I correct? Okay, so we have two values of sine t, which is uh, positive 4 over 5 and negative 4 over 5. But the problem is, okay, so for the 6 trigonometric functions, but the problem, since this point, the t is in quadrant 4, therefore sine t is negative. Okay? Do you still remember the signs of each coordinate? If, if the point lies in the quadrant 4, the x-coordinate is positive and the y-coordinate is negative, which corresponds to sine t, right? So therefore, since the point is in quadrant 4, therefore the sine t is negative. Okay? So instead of, since we have two values of sine t, right? And since we are given the condition that t lies in quadrant 4, so we disregard the positive 4 over 5. Okay? So sine t is equal to negative 4 over 5. Okay. So now that we know that both sine t and cosine t, so we already know the value of sine t and cosine t where the point lies in quadrant 4. So we can now find the values of the other trigonometric functions using the reciprocal identities or the fundamental identities that we have discussed earlier. So we have sine t is equal to negative 4 over 5 because the point lies in the fourth quadrant. Cosine t is equal to 3 over 5. This is given. Okay. Then tangent t. What is tangent t? Is equal to sine t, the formula. Okay, what's the formula? It is sine t over cosine t. And since the value of sine t is negative 4 over 5, substitute over the cosine t, which is 3 over 5. Then simplify, we get negative 4 over 3. Therefore, tangent t is negative 4 over 3. How about cosecant t? Cosecant t is defined as 1 over sine t. Then since sine t is equal to negative 4 over 5, so we have 1 over negative 4 over 5, which can be simplified into negative 5 over 4. How about secant t? Secant t is defined as 1 over cosine t. Okay? Now, since our cosine t is 3 over 5, therefore we have 1 over 3 over 5, which can be simplified into 5 over 3. So secant t is equal to 5 over 3. How about cotangent t? Cotangent t is defined as 1 over tangent t or cosine t over sine t. Correct? So since we are given the value of tangent t, which is negative 4 over 3, so we just simply divide 1 by negative 4 over 3, which can be simplified into negative 3 over 4. Okay, so that's it. That is how we use the trigonometric identities in order to get the 6 trigonometric functions given given a specific condition in a specific problem. So thank you so much. Hope you like this video. And again, don't forget to practice. Always practice. Then you can now, once you are ready with your answers, so you can show your answers in the comment section or you can email me with your answers. And do not also forget to share the learning that you've got from this video or this lesson. Thank you once again and God bless.